Here's a problem, pretty typical that you find in a physics book here. It's a mass M2 on an incline connected by a rope to M1, which is hanging. The rope is massless, the pulley is light and massless, and the question will ask some pretty typical things here, like what is the acceleration on the blocks, and what is the tension in the rope. So why don't we go out and find those things. We're going to follow our usual prescription, recognize forms of Newton's laws for each block. We identify the forces. We're going to put in some sign conventions, then we're going to go ahead and fill in the equations 1 and 2 and see what we get. So let's identify some forces. And we'll assume you've watched some of our earlier videos and getting kind of good at this stuff here, so we'll try to skip some of the details and just get right to the core here. Okay? On M1, I see an M1G down, that's its weight, and I see a rope pulling up on it. Ropes always pull away from the points of contact, so there's a couple forces right there. On M2 here, I definitely see a tension pulling back up, pulls away from the point of contact. I see some gravity down like that, would be an M2G. I see a normal force pushing up like that, and although it's not really a real force, but it's something we try to get used to here, there is definitely a sliding force on this mass on the incline. You can watch the previous video to see where that force comes from, but we'll just say there's a force which causes it to slide down the incline. It's good to sort of get it in your head and recognize these things, and there you go. So I think we've identified all the forces on this object here, on both objects. Let's just get going then with Newton's laws here. Equations 1 here, and I guess we'll just start with mass M1. Good enough place to start. So on mass M1, I don't see any X forces on this hanging mass here, so we're not going to use the equation, although it's valid. I do see some Y forces. So then A sub Y then is going to be the tension minus the weight. And the reason why I paused is because I'm getting ahead of myself. And I forgot step 4 to identify some signs. So we'll just pause here just for a second, go back to the problem and try and get some signs on there. Let's just call down negative over here and up positive right here. But tensions on opposite ends of rope have opposite signs, so this is a plus T, that's going to be a minus T. There's a minus T right there, that'll be a plus sliding force right there. And I think that'll do it for now. And so let's just continue with the problem then. We might have some signs to fill in a minute, but for now I think we're good. So the Y forces on the hanging mass, again, no X forces. The sum of the force then is a plus T minus an M1G over M1. That's an equal sign right there. There's a Y acceleration on that hanging mass, and we're sort of done with it for now. Okay, quick, huh? Now what we'll do is we'll go to the object on the incline, and like the last problem where we did one mass on an incline here, we're going to call this axis right here that sort of runs parallel to the incline, we're going to call this our big x-axis right there. The y-axis, of course, will be right here. We'll sort of run it that way. So when we run Newton's laws here, this says sum the force along the x-axis. We're going to be looking along this direction of motion to get that to work out. So let's just hit it then with mass M2. So here we go. The one on the incline. So we'll say the x forces, the x acceleration is the sum of the x forces divided by the mass. We'll look at it. We have everything in there, I think. We have the sliding force. We have plus sliding force minus tension. That's all I see there, divided by M2, and we're sort of good. We'll continue on a bit and use some of the analysis which we did in an earlier video, but something you can just have depending on how confident you are, what steps your instructor wants you to fill in there. We know the sliding force is always going to be M2 times G times the sine of theta. That's the force that wants to cause things to slide down the incline. Minus T will still be in there, divided by M2. And if we put a big box around this, we got it. We got the acceleration of that system there. And we're making some pretty good progress here. We can almost answer the original question here about what is A and what is T on this particular problem here in this manner. If you look at the two equations here, this is the vertical acceleration of this block. This is the acceleration along the incline of that block. Now, the two blocks are connected by a rope. So what that means is that the accelerations of them are the same because they're connected by a rope. That means the AY, the hanging block, is the same as the AX of the block on the table. These are going to be the same accelerations. So a couple of things you can do to proceed then, that is, this acceleration is the same as this one here because the items are connected by a rope. You can just call these, you can dispense with the AY and the X and just call AY and the X. You can just call that A. You can call this A if you want. And then what you can do is rewrite the equations. There's a couple ways to proceed. This is just one here. You can rewrite that top one for M1 there as plus T minus M1G over M1. That'll be fine. And for this one right here, you can rewrite this A as plus M2G times the sine of theta minus T over M2. So I've just rewritten the two equations I formed, but instead of the AY and the AX, I've just replaced that with A because A is the same across both blocks. And there you go. You've got two equations for A there. Now, we'll just sort of stop the video here because the rest is just a bunch of algebra. You have two equations and two unknowns. You don't know T here and here. You don't know A there and there, but that's okay. It's two things you don't know, but you have two equations. So with a bit of algebra here, these things can be solved for A, and you will get your acceleration and you will get your tension, and that'll be your answer. That will be your answer to the problem. And that's the way this problem is going to go.